So, in the last episode, we looked at ownership and references and borrowing. I'm not sure how much of that I remember, to be honest, but I do remember that it was pretty cool, pretty interesting. I think Rust model of like how to avoid to have a GC is very interesting. And so today I wanted to do something that I actually already did in one of the previous episodes. You may notice that one of the episodes is gone. I think episode 3 is missing, and that is because I recorded it and I don't know, somehow the video was frozen, so only the first frame was showing for the entire video. So I will be doing what I did last time again, which is a very stupid program that basically asks the user two numbers and operation that they want to perform on them and prints the results. This is just so just to try it out, a few of the things we saw, and also see if I remember anything from last streams. So we're gonna create this project. We're gonna call it in a very optimistic way calculator. Cargo new, of course. Yeah, this is a good start. Okay, and then we can open Visual Studio Code here. Okay. So what is this thing gonna do? This thing is going to so we're gonna ask the user for an operand, ask for an operator. Is it like, what is the definition of operand again? I want to say operand. The following arithmetic expressions show an example of operators and operand. The above X plus is the symbol of the operation called addition. The operand 3. Okay, so we ask for the operation for 2 operands. And then we're gonna print the result. Okay, so first of all, what we are gonna need is a function that reads a string from standard input. We're gonna need it for all the for everything, basically, for the operation, for the operands. So let's have you can see that I am writing too much Kotlin lately. Read input, let's say, and this function will return a string. Okay, and I think to do this we needed to use standard IO or something like this. Yeah, but I have absolutely no recollection of how am I gonna do this. So let's see. I think we can look at some of the, for example, guessing game, I think, had this code. Yes, so we from standard input with we create a string, a mutable string. We pass it to the readline function, and so basically readline will populate this string with what the input inputs, and we use expect to basically panic if there is a failure here. Okay, cool. I think this makes sense. So we're gonna have our mutable input, which is a string new, and then we are gonna do something like standard in, I think it was std in what was it, readline and we pass the a reference to input, so we know that the ownership will not be moved, and this is just a mutable reference, so we cannot have another mutable reference, because from last time we said that at any given time you can either have one mutable reference or any number of immutable references. Actually, why don't I just make this full screen? Yeah. Otherwise, and this read line will return a result object which can either be OK or error, and we want to just panic the program if the result was not OK. Actually, I think it was expect. Let's see. Is it expect? It is expect. So fail to read from standard input. Okay, and then we are gonna return. Actually, in Rust, the last expression is what it is returned. So I believe that this should work. Actually, let me also take out a terminal from here. Can I move it here? No. I don't like it. Let's do it like this. Let's do it like this. Okay. And let's see if I can build this. Okay. Yes, of course, it's not used yet, so it is complaining, but we don't care. So first of all, we're gonna ask for an operation. Actually, it would be cool not to print a line, but to print without the new line at the end. I wonder if I can just try. I think maybe this will not put the new line in the end. Let's see. It is not putting the new line in the end. That's perfect. Okay, so we ask for an operation. We read it. So we read the input, and then we ask for an operand. Actually, let's start from this. So in the end, we do actually print some stuff with a new line in the end. Let's just print back the operation for now. Let's see. What? Okay. Why isn't it printing the operation? Weird. Let's see. Rust. Oops. Rust print line without new line. How do I print output without a new line in Rust? You can use the print macro instead. Now the standard output is frequently line buffered by default, so it may be necessary to use standard output flush to ensure the output is emitted immediately. Wow, seriously? In C++, okay. Okay, so it seems that to have this working consistently, we can also have our own function, which we can call prompt, which takes a message, which is a string, or rather, actually, it's not a string. It's a reference to a str thingy, I guess. So, and what this will do, because this is a string literal basically. If I recall correctly, this is the correct type. So what this will do, it will print the message without the new line, and then we are gonna flush the standard output to make sure that the message is actually printed to the user. And that's it. So we can replace this print with prompt. Let's see. And of course it doesn't work. So you might be missing. Oh, I see. Okay. So we need to do this basically. Flush method not found in standard output. Why not? I believed in you, Stack Overflow. Why not? Oh, items from traits can only be used if the trait is in scope. The following that trait is implemented but not in scope. Perhaps. Okay. So basically we need to add this use statement. This is a bit confusing. Okay, I think it's because it's one of the other cases in which this method is actually implemented by whatever standard output returns, but it's the definition is in standard IO, right? So I guess that's why we need it. Okay, we get a warning. The result may be an error variant which should be handled. Actually, I also want to panic here. I don't care about handling this error, so let's just expect failure to flush buffer or something. But let's just write this. I also forgot to have a nice, maybe I can do it live. So Rust formatter, Rust syntax, Rust prettier. This was deprecated. Okay, I would need to, maybe this one. Okay, let's not do it here. I just need to set a Google task or whatever to remind me to do it. Okay, so 3. Okay. What the fuck did I do here now? Okay. So let's see, operation plus. Okay, nice. So now we have a prompt. That is very nice. It doesn't print a new line, and it also actually does print to the user, and it accepts a string literal and just prints it to standard output. And we have our read input function that will return an input string from the user. So we are asking an operation, then we can ask for operand twice. And then we can store what we were asked with operand 1, actually, or let's say first operand and second. Okay, and then we can print something like this. So first operand operation, second operand equals whatever that we don't know yet. Let me also resize a bit this. So operation sum 1 plus 2 equals 3. Okay, so we can already see a couple of issues here. So the first one is that everything has a new line. So, and I believe this is not what we want. And I think we may just be able to trim this to remove the new line. Let's see. Okay, trim is not. No, wait, what? So expected trim because of return type, but trim. So trim returns pointers to a string lit. What is this? This thing called? Unexpected. Actually, we don't necessarily care that this is not a a string. I think actually maybe we even don't want to return something that is mutable. But how can we, like, this is a reference to a string? How can, let's search Rust trim string. What is this? Okay. Yes, but without allocating another one. Okay, people are mutating the string, but trim returns a string slice. Okay, so this is how this is called, a string slice. But I don't necessarily want to return a string slice, to be perfectly honest. Actually, I think we already did something similar for the what was it, for the guessing game, right? We were using numbers here as well. So because the second problem we have now, so the first problem is that there are new lines. Everything that we are reading, of course, contains a new line, because the new line is the last character we get when we print enter here. But the other is that first operand and second operand are strings, but of course they should be some sort of number type. So let's see, what did we do? Oh, we used trim and parse. Okay. But I wonder, like, so if I return a reference here, can I just return a reference? Like, would this even work? Like, is a reference to, like, who owns this string now? This string slice. Named lifetime parameter. So what? This function return type contains a borrowed value. Exactly, yes. But there is no value for it to be borrowed from. Consider using the static lifetime. Let's see. Rust return string slice. Proper way to return a new string in Rust. Okay. Oh, okay. So maybe I should. Yeah, we don't want to do, so as a general rule, I don't want to use things that we didn't see in the book yet. So I guess it's already a good thing that I was expecting this not to work, but I'm not gonna add this static whatever thing. And the other thing that you cannot return a string. Yeah, exactly. So this we cannot do, but I also don't want to pass the string as an argument or whatever. Okay, so you know what? I guess we're gonna make this code slightly uglier, because I want to trim it here, and then I expect this to be okay-ish. So we can trim the operation here. Of course, this is not a reference to a slice, but just a string. Creates a temporary value is free at the end of this statement. Creates a temporary which is freed while still in use. What? Oh, I need to consider using let binding to create a longer lived value. Okay, but couldn't Rust do this implicitly for me? Do I really need to assign this to a variable? This is a bit annoying. So let's go to plan C, I guess, which is, let's move to the operand first. So obviously I do not want the operand also as a string. I want them as a number. So let's just create a new function, which is read operand, that will return an integer 32. What was the I32? Yes, I think. And what this will do, it will return read input, trim, parse, and then I guess this can also fail. But yeah, we will just fail. We will just panic the program if this returns an error. So this, what can we say? We can say invalid operand or whatever. Okay, and then here we are gonna say we are gonna call read operand instead of read input. And let's just check that this works. Plus 1, 2. Okay. As a side effect, you can see that already 1 and 2 are in our number and not string, and also that they are, I mean, you cannot see it here, but you can see that there is no new line anymore because we are using trim. How long is this line? This is becoming a bit 65. Okay. Maybe I can decrease slightly. Okay. Okay. So now we have our operation. We have our first and second operand, and we need to actually do whatever to actually calculate the result. So we will have our result, which is, we're going to use the match expression. Let's see if I remember anything about this. Oh, actually, I can just copy from here. Okay. So we can... actually, this is not strictly what I want. So... but I can guess what this is. So basically, we can guess the operation, the trimmed operation, and it's either sum, and then result is going to be first operand plus second operand, comma, or it's going to be multiplication, and then this is going to be first operand times second operand, or what are we gonna do in this other case? I think it's something like this. Let's see. Rust match default. Match expressions, match. Yeah, I don't want the grammar, I want an example. Okay, yes, it's this underscore thingy. I think I saw it already last time when I kinda already wrote something similar. And now, again, I want to panic this program. Rust panic. Panic in standard. Oh, it's a macro. Okay, we know how to use macros. And of course, I would never write a program like this in real life, of course. Like you would like properly handle errors and whatever. So we can say that operation is not a valid operation. I guess it expects a string or whatever, but we will see, I guess, if this thing compiles. And then here we're gonna print the result. Cargo run. I need a, of course, we need a semicolon to complete the statement. I cannot type. What the? So we want to sum 1 and 2 to get 3, but we really want this operation trimmed. No, are you really gonna make me? I really don't want to do this. Wait, let me see what the error was. I really don't want to create a variable just for this, but maybe we can Google for some better solution. Temporary value is free at the end of this statement. So creates a temporary which is free while still in use. let's see. Whoops. So Rust. Okay, let's see. How did you solve this problem? Variables are semantically meaningful in Rust. Expression assigned to a variable is longer than the same expression used. Okay, yes. Okay, so we really need to this variable, I guess. Okay, that's unfortunate. I guess this is one of those examples of things that like may not be obvious, and with this new way of like having to deal with memory, this is one of those side effects. So what can we, so let's call this raw operation, also known as the untrimmed value, and then operation is going to be raw operation trimmed. Let's see, are you happy now? You are happy, yeah. Okay, great. Yeah, this worked out pretty well. I think was a very, of course, this is a trivial example, but still we saw a few things. I guess, should we do it inside a loop? I feel like I have no idea how to actually like write a loop. I don't remember. Let's try. I think we can have an infinite loop like this. And of course I don't have a formatter, so I'm gonna need to be this barbarian operation of actually indenting things myself. And maybe we also want to have another new line at the end, just so we can. So I want to sum 1 and 2, and then I want to multiply 9 and 9. Wow, crazy, cool. It seems to work. Very nice. Okay, I guess we can, well, we should update the documentation to reflect that repeat is the last step of this cycle. Yeah, so this was a surprising consequence of how Rust handles memory, I guess, or like handles free memory, which is a good thing that we encountered like so early. And yeah, otherwise I would say let's move on. Let's look into the next chapter in the book, which is the slice type. So basically, I think we already saw it, because the slice type is apparently this is a slice of a string. But let's see a more formal like description. So slices let you reference a continuous sequence of elements in a collection rather than the whole collection. Slice is a kind of reference, so it does not have ownership. Okay, so is it like kind of like a pointer to a section of an array or whatever? Let's see. So, a small programming problem. Write a function that takes a string of words separated by spaces and returns the first word it finds in that string. If the function doesn't find a space in the string, the whole string will be one word, so the entire string should be returned. Okay, let's work together. Okay, this sounds like a very simple problem. Let's work through how we write a signature of this function without using slices. Understand the problem. That's slightly we solve. Yeah, so what would you do? You would pass a reference to a string, because you probably don't need to change ownership to it. And then what would you return? Well, I would actually return another string. Like I would return a new string, right? I know that this would probably mean that we would need to, since this is not a mutable reference, and anyway I wouldn't want to edit to change the original string, I would just return a string, a new string. But maybe this is too expensive for a system programming language. Let's see. The first word function has a reference to a string as a parameter. We don't want ownership, so this is fine. What should we return? We don't really have a way to talk about part of a string. Yes. However, we could return the index of the end of the word indicated by a space. So again, I think I am too much of a Java engineer, because I would, like, if you ask me this, returns the first word it finds in the string. For me, this is another string. But anyway, I can see that why you would not want to create a new string, whatever. Yes, we can also just return the index. So basically, what are we? Oh, we are transforming the reference of a string to something collection of bytes. We create an iterator on this and we enumerate. I guess this returns like a collection of pairs of the index in which we are and a reference to the item, so that we can return the index. And so of course, as soon as we see the byte for the space character, we return the index, because this is the end of the string basically. So we could return the index of the end of the word, exactly, yes. Otherwise, we return the length of the string, because it means that we never find a space, and so this would be the this would mean that the whole that S is a single continuous word, and yeah. So of course this is a bit ugly and probably not super useful. So because we need to go through the string element by element and check whether a value is a space, we'll convert our string to an array of bytes. I hope you can just iterate over characters in a string in Rust without having to do this very ugly thing, but maybe not. Next, we create an iterator over the array bytes using the iter method. Okay, we discuss iterators later. Iter is a method that returns each element in a connection, enumerate wraps the result of iter, and returns each element as part of a tuple inside the S. So basically, these are, of course, yes, these are tuples. One is the first element is the index, and the second is a reference to the item that this index points to. Okay, makes sense. So this is basically how we were expecting, like what we thought it would be. Okay, since we can use patterns to the structure that tuple, yeah, cool. Again, we will see this later. Blah blah blah. Okay, basically we already discussed all this. Okay, we now have a way to find out the index of the end of the first word in the string, but there's a problem. We are returning a use size on its own, but it's only meaningful number in the context of the reference to a string. Okay, and since this, I guess, since this string you could still mutate it, there are no guarantees that the index that you are returning now will remain valid in the future. I guess this is what they're saying. Okay, for example, let's say that we create a new mutable string from this what's the name of this type of strings? Not string literals, sorry. We get the index of the word, so it's gonna be the index of the end of the first word. So this is gonna be 5. So the index to this character, and then we clear the string, and now this word index is completely not valid anymore. Okay, makes sense. So having to worry about the index. Okay. Okay. Yeah. Having to worry about the index in Word getting out of sync with the data in us is tedious and error-prone. Manages these indexes is even more brittle if we write a second word function. Now we are tracking a starting and an ending index. Yes, of course. And then it's even harder. Blah blah. So instead, we use string slices. Okay, a string slice is a reference to a part of a string. And it looks like this. Okay. So so it seems like this is like you get a part of the string. So basically this is a range and you access it like this and you get a reference to this. Okay. Okay, so slice is a reference to a portion of a string. We create slices using a range, yes. Internally, the slice data structure stores the starting position and the length of the slice. Okay, makes sense, which corresponds to ended index. Okay, of course. Okay, so S is our string, so there is a pointer to a section in memory. There is a length and capacity. I think we already discussed or touched upon this. And inside word, which is this slice, it will point to the start basically of the slice and how long it is. So like 5 in this case. Okay, cool, I guess. Okay, with Rust dot range syntax, if you want to start at index 0, you can drop the value before the 2 periods. Okay. If your slice includes the last byte of the string, you can drop the trailing number. Okay, makes sense. And of course, this would be to match everything. Okay. Note, string slice range indices must occur at valid UTF-8 character boundaries. If you attempt to create a string slice in the middle of a multi-byte character, your program will exit with an error. For the purpose of introducing string slices, we are assuming ASCII only in this section. Okay. Okay, and so now we can finally actually do this properly. And so the code is very much similar to what we had before, but when we find the space, instead of returning this index, we return a slice that starts from the beginning of the string and ends at this index. Or otherwise it will return everything. Okay. Okay, now when we call first word, yes, of course. But the real question is, what happens when you mutate the string now? Like, can you even do that? Maybe you cannot do it because there is a reference, because there is a slice around. That would be a good thing, I guess. We now have a straightforward API that's much harder to mess up because the compiler will ensure that the reference into the string remain valid. Yes, okay. Okay, using the slice version of first word will throw compile time errors. So basically, yes, you cannot clear it because there is a slice, which is word, that is still in scope. What is the error? Immutable borrow occurs here. Mutable borrow occurs here. Okay, the borrowing rules that if we have an immutable reference to something, we cannot also take a mutable reference. Yeah, exactly. And this would take a mutable reference to what? To self? Because clear needs to truncate the string, it needs to get a mutable reference to itself, I guess. The print line after the call to clear uses the same reference in word. Okay, so the immutable reference must still be active at that point. So, and you cannot have both a mutable and immutable references, so this is not allowed. Okay, nice. String literal are slices. Okay, I want to make a very like wild assumption of why string literals are slices. So maybe, a string literal is known at compile time. So maybe all the strings that are known at compile time will just be allocated at as a continuous string in memory, and so you get this section of this memory that is the slice you want, that is the string, the literal you want. I have no idea what I'm talking about. Let's see. Okay. So string literals are stored in the binary. Okay, is a slice pointing to that specific point of the binary. Yes, okay. This is also why string literals are immutable. Endstr is an immutable reference. Okay. String slices as parameters. Oh, actually, this is exactly the problem we had before when we wanted to trim it here, but then we couldn't return it from here. So let's see. Knowing that you can take slices of literals and string values leads us to one more improvement on first word, and that's its signature. Because it'll okay. Okay, yeah, sure. So we can. So in this case, we can return the slice because the string is not owned by this function. I still don't know if it's correct to say owned by this function. It is owned in this, is active in this scope, so it's active outside, and so it still survives when we exit this function. So it's not actually this problem that we had before. So a more experienced Rustasian, how do you pronounce this? Would write the signature shown in listing 49 instead, because which is it this one, the 49? So let's see, what did we have before? So before we would return okay, so this is the original signature, but instead some Rustasian, I guess someone that writes Rust, would actually use a slice here, because this allows us to use the same function on both reference to a string values and slice to a string. If we have a string slice, we can pass that directly. If we have a string, we can pass a slice to the string or a reference to the string. Okay. Yes, I guess you can just transform the string to a slice of the entire string, and this would still work. This flexibility takes advantage of the deref coercions, a feature we will discover later. Defining a function to take a string slice instead of a reference to a string makes our API more general and useful without losing any functionality. Yes, so here instead of passing my string, we pass a reference to my string only to a section of it for some reason. But we could also, just pass the whole slice. Okay. Okay, so far we saw slices only for strings, but I guess you can. There are slices for arrays too. Just as we might want to refer to a part of a string, we might want to refer to a part of an array. We would do it like this, okay, with the same syntax basically, but just instead of str here, or like actually what am I talking about? Yes, it's exactly the same format, and the type is okay. Instead of being like ampersand, str is ampersand square brackets i32 square bracket. It works the same way as string slices do by storing a reference to the first element and the length. You'll use this kind of slice for all sorts of other collections. Okay. Cool. So this, I think Go has something like this. It just doesn't come natural to me. Like I would not return. Like I guess it's because Java doesn't offer this ability in a like very simple way. So that's probably why I would just think that the first word function should just return a new string. Yeah. So the concept of ownership, borrowing, and slices ensure memory safety in Rust programs at compile time. The Rust language gives you control over your memory uses in the same ways as other system programming languages, but having the owner of data automatically map that data when the owner goes out of scope means you don't have to write and debug extra code to get this control. Ownership affects how lots of other parts of Rust work, so we'll talk about this concept further throughout the rest of the book. Okay, and next chapter is about structs. Okay, to structure related data. Okay, cool. So I guess we finished this section of the book, right? This chapter on understanding ownership.
This was the most interesting chapter by far. I think I have a better understanding of what Rust is now and how it works, and especially this. I am glad we did this short exercise to see for the first time one of these how can I call them, like rough edges that how Rust works brings to your code. Like I would not expect this to be actually meaningful. Usually you can safely just inline this, but of course in Rust actually assigning a variable has a bigger meaning than just labeling some stuff. So yeah, cool. I will try to stream again this week, maybe on Thursday or Friday. Yeah, I think this is going very well. Of course, not many of you are watching, but I was expecting that. But having to I am kind of sticking to it, and I can plan to continue doing so. So if you have any suggestions of what we could do, please let me know. Otherwise, have a nice evening, night, day, whatever your time zone, whatever is more appropriate for your time zone. See ya.